Hi there. This is gonna be another video about the false position method, but this is gonna be an important one because a few videos ago I said that it's almost always the case that we're gonna find an approximation of the solution, not the real solution. And then going on and on and on with the iteration, eventually we can find a closer and closer value to the solution and so on. But in this case, we're gonna find the solution. Yes, we are gonna find the solution. So, with this in mind and getting ready for this very good exercise of math, we're gonna write our function. So basically our function is gonna be f of x equal to x squared plus 3x plus 1 equal to 0. And as a starting point, we're going to choose the two starting point x1 and x2 so that once we plug the values here inside my function, I'm going to get a positive value and a negative value. So since the function is continuous, we know there must be a point in which it's going to be 0, so in which it's going to intersect with the axis. And we're looking for that point. And I promise you that this time we're going to find exactly that point. All right, so as x1, I'm going to choose negative 0.5, and as x2, I'm going to choose 0. So let me just plug negative 0.5 into my function here. So I basically get negative 0.5 squared plus 3 times negative 0.5 plus 1, which is going to be equal to 0.25 minus 1.5 plus 1 equal to negative 0.25. And if I plug in f of 0, I get 0 squared plus 3 times 0 plus 1, which is actually going to give me O plus O plus 1, so 1. Alright, so we got a negative value and a positive value, so everything is fine. So we can actually draw the sketch of our graph. X, Y, this is going to be the 0. Alright, so our starting point is going to be 0, so here, the origin, and negative 0.5, which I'm going to draw here, negative 0.5. So we know that at negative 0. Negative 0.5, we're going to get negative 0.25. So like here, negative 0.25. There we go. And we know that the 0, the function is actually positive and of value 1, which we're going to draw here, like at the very top. So here. Right, so it's gonna cross somewhere in between. Okay, so now I'm gonna write the formula as I always do. So for the false position method, we have xr equal to x2 times f of x1 minus x1 times f of x2, everything over f of x1 minus f of x2. There we go. So as I promised you, this time we're gonna find the exact value in which the function is gonna be 0. So let's start. Let's crack on and start. xr1. So xr1 is going to be given by x2, so 0, times f of x1, so negative 0.25, minus x1, which is negative 0.5, times f of x2, so 1. Everything over f of x1, so negative 0.25, minus f of x2, so 1. And in this case, we're basically going to get 0 minus negative 0.5 over negative 1.25. So this is actually going to give me 0.5 over negative 1.25, which is like saying negative 0.5 over 1.25, which is going to give me negative 0.4. So the value we have just found is negative 0.4. So we're getting like here, like going to this point here, negative 0.4. So let's just try to plug in negative 0.4 into our function. So basically f of negative 0.4 is actually going to give us, well, actually going to give us negative 0.4 squared plus 3 times negative 0.4 plus 1. Which is 0.16 minus 1.2 plus 1, so negative 0.04. So we're getting closer, we are really getting closer to 0. So we are like here, negative 0.04. So, you know, you can see that we're really getting closer. Like, we're really getting close. We're almost to 0, but negative 0.04 is quite not 0. It's quite not the point in which the function is gonna intersect the axis. And I know you watched the other videos and you're gonna say, okay, you're gonna get it closer. But no, this time I'm gonna get the solution. So let's go on and go to XR2. And this time, at this very try, we're gonna get the solution. So XR2 is actually going to give, well, I'm going to use negative 0.4 as my x1 and 0 as my x2. So xr2 is going to be given by x2, so 0 times f of x1, so negative 0.04 or negative 0.04 minus x1, so negative 0.4 times f of x2. So f of x2 is actually 1. Everything over f of x1, so negative 0.04 minus f of x2, so 1. Alright, so now we're gonna get, if we compute this, you're gonna see, you're really gonna see, you're gonna get 0 minus negative 0.4 over negative 1.04, which is like saying negative 0.4 over 1.04, which gives me negative 0.38, and this is gonna be exactly negative 0.38, exactly the point in which the function is gonna be 0. You don't believe me? Sure. Of course you shouldn't. So let's just put f of let's just compute f of negative 0.38. So let's just put negative 0.38 back into our function. So we get negative 0.38, which is back into our function is negative 0.38 squared plus 3 times negative 0.38 plus 1, which gives me 0.14 minus 1.14 plus 1. And guess what? We're basically gonna get, well, 0.14 minus 1.14 is just gonna be, you know, the 0.14 and 0.14 cancel out, so it's gonna be negative 1 plus 1. So negative 1 plus 1, they all cancel out. So yes, victory, 0. Exactly, that's exactly right. So 0 is actually gonna be the point in which this function is gonna go, you know, intersect the axis. So basically 0. So 0.38 is actually going to be the point in which the function is going to intersect the axis. So I didn't draw this point correctly, but this is actually going to be like this. So this is going to be our function. I'm sorry that it's not, on scale, because I'm a terrible I'm really terrible when it comes to writing graph and sketching graphs. But this is the important part. This is here. So with this method, anyway, we found the exact point at which is going to intersect the axis. Isn't it cool? So that's it for this very moment. But I'm gonna do one more video.